This video will be part 1 of the Unit 5 test review. So in this first question, it says y equals x squared plus 8x plus 17. And what you're asked to do is to sketch a simple graph that includes the vertex and the axis of symmetry and whether it opens up or down. So the first thing that we can notice here at this is the standard form of the quadratic. So ax squared plus bx plus c. And the a value, with it being positive, means our graph is going to open up. So the vertex is going to be the minimum value. But what we need to do is find the vertex. And we've learned and we've practiced, we start with finding the axis of symmetry, which we use this equation, x equals negative b over 2a. So I'm going to go ahead and work that out now. So the b value is a positive 8. So when we plug in x equals negative b, we'll write negative 8 over 2a, which is 2 times the a value is 1. So negative 8 over 2, which equals negative 4. So we know that x equals negative 4. And that's going to be x of the vertex, because that x equals negative 4 is the axis of symmetry, which goes right through the vertex. So x equals negative 4, and what we need to try to do is figure out what is the y value. Well, we're going to figure out y by plugging in x as negative 4 and just work it out. That's how we find the vertex. So let me work on that. So here you can see I've written y equals x squared plus 8x plus 17, and I've replaced the x with the negative 4. And when you square negative 4, you get positive 16, and then 8 times negative 4 is minus 32, and then of course plus 17. 16 minus 32 is negative 16, and then plus 17 is 1. So the y value of the vertex is 1. So now we know the vertex is at negative 4, positive 1. So we can come over here. We can put our vertex at negative 4, 1. This is the axis of symmetry. So we know that our graph, because the a value is positive 1, we're actually going to go up 1 and to the right 1 and up 1 to the left 2. So we'll put those points there, and we know that our graph opens up. Something like that. Okay. Okay, let's take a look at this one. Again, we have it in standard form. So we're going to need to start by finding the axis of symmetry with x equals negative b over 2a, and just plug everything in. Our b is here. It's negative 12. So when we write negative 12, or if I were to write that out, x equals negative 12 over 2 times 2. This 2a, a is now 2 in this problem. B is negative 12. Well, negative 12 is actually positive 12. So this is 12 over, and 2 times 2 is 4. So 12 over 4 equals 3. So what we know is that our x equals 3, which means in our vertex, or the axis of symmetry, is actually x equals 3. So we're going to have this axis of symmetry here of x equals 3, and we are trying to figure out what the vertex is, and then we can plot the vertex, and we know that this one also opens up based on this 2. All right, so now what we need to do is to plug 3 in where we see x. Now in this problem that you're asked to sketch a simple graph determining the vertex, the axis of symmetry, and whether it opens up or down, this graph is already in vertex form. Remember, vertex form is y equals a times x minus h plus k, where the h and k actually tells us what the vertex is. And then the a value, again, determines if it opens up or down. And remember, inside these parentheses, it shifts right or left, kind of opposite of what you think, and the k is what shifts it up or down. But this is already in vertex form, so we know that the h is 3 and that the k is negative 2. So in this one, we already know our vertex, and our vertex is again at 3 for the x value, 3, and then the y value is the negative 2. So 3, negative 2 is our vertex. So we go over 3 and down 2, And we know this represents our vertex. And remember, the axis of symmetry in this one will be x equals 3. This is the axis of symmetry. But when we talk about whether this graph opens up or down, we look at the a value. It's a negative, so we automatically know it opens down. It's actually a -1, so we could plot that point by going down 1 for the -1, and we have a point to the left and a point to the right. So we put a point here and a point here, and our graph opens down something like this. All right, let's take a look here at number 4. Again, y equals 2 times x minus 1 squared minus 3. This is in our vertex form, where we have y equals a times x minus h squared plus k. And if you look here, we have the h and the k. The h is going to be the 1, and the k is going to be the -3. So that is our vertex, 1, -3. So we can automatically plot our point at 1, -3. So over 1 down 3, that would be right here. And then if we were going to plot this, we need to know the a value. The a value is 2. That means it's positive, so we know it opens up. If we just wanted to simply sketch it opening up, we could, but we know the a value is 2. That means from the vertex, we're going up 2, and then 1 to the right and 1 to the left for our first point. So 1 here, and then we can just sketch that graph going up. And that's a simple sketch of that parabola created by that equation. All right. All right, in this section of the test review, which is very similar to the test, you're going to be asked to identify the transformation from the parent function to the given function. So all of these functions are in vertex form. Remember the vertex, the parent function vertex is at 0, 0. But whatever happens inside the parentheses shifts it right or left, okay? So definitely remember that the parentheses shifts it right or left, and that the k value shifts it up or down. Now, inside the parentheses, we kind of think about it doing the opposite of what we would think because of the -h. So if it's a, looking at number 5, inside the parentheses, we have a +4. That's actually going to shift it to the left 4 units. So, yeah, it's going to shift to the left 4 units. Then we have this +4 for the k, and that's going to shift it up 5 units. I'm sorry, up 4 units. Now, the other thing we need to consider is the a value. That's a 2. That's going to deal with what we call vertical stretch or vertical compression. If it's a number greater than 1, then it's a stretch. It's being made skinnier, okay, vertically. All right, so again, the answers for this one is that it shifts left 4 units, it shifts up 4 units, and it's a vertical stretch by 2. And we also want to identify that it opens up. And we know it opens up because of the positive a value. All right, looking at number 6, we have y equals -x minus 2 squared plus 4. So we can see inside the parentheses, it's a -2. So that's going to shift it to the right 2 units. The +4 for the k value is going to shift it up. And then we can see here that it's a -1. There's not going to be any stretch or it's no vertical stretch or vertical compression, but the negative is going to tell us that it opens down. So the answer to number 6 is that it shifts right 2 units, it shifts up 4 units, and this negative means that it opens down. All right, let's take a look at number 7. All right, y equals x plus 2 squared plus 1. So again, we have a +2 inside the parentheses, so that's going to shift it to the left 2 units. The +1 for the k value is going to shift it up 1. And then you will see that there is no, or the a value is actually 1. It's not written, but that means that, again, there's no vertical stretch or vertical compression, and it is going to open up. So we simply state that it shifts left 2 units, shifts up 1 unit, and it opens up. All right, last one here, x minus 1 squared plus 4. We have the shift to the right of 1 unit and a shift up of 4 units. Looks like they all shift up 4 units. And again, there is the A value is the 1, so there's no vertical stretch or compression, and it opens up. All right, and that's a look at identifying transformations.